All right, so these are your formulas that you need because we're looking for volume today. And what is volume to you? It's area integrated. So if you knew the area, you could integrate it and you'd have volume, right? So these were the ones that I recommended you take the time to write down on a Post-it note, right? I don't know if you necessarily need to write a rectangle and a square down. I think you pretty much know those. But I would write these on a Post-it note, then I can stick them up on my computer screen or whatever I'm doing at home on the bulletin board, and I can look and see my formulas and not flip. So let's talk about what we're doing today. We're going to take a shape. You don't have to sketch this, just watch with me. Right? Maybe I get a shape, right? There's my shape. And that's a slab, kind of like your driveway, right? And we're going to put something on it. Maybe I have squares sticking out of the top of it. Let me cut those. And I'll show you some 3D models. Right? So maybe I have squares sticking out of the top of this, right? So the top minus the bottom would give me the length of the square. And if I knew one side of a square, I'd know the other side and I could find the area of that square, right? It's whatever the top minus the bottom is. And then if I integrate that, it fills this space with infinitely many, and I have a 3D shape that I can find the volume of. For instance, here's a shape. Let's say that we take top minus bottom to find the length of this shape, and then I tell you I want you to put semicircles on top of it. We get a three-dimensional shape. Do you see what we're doing? The whole length of your paper, you're making imaginary slices. This symbol, right, the integration symbol, cuts this into a gazillion slices and puts them together, and that makes a 3D model. If I had a circle as my bottom, and then I put semicircles on top of it, see how they would change size? That's why we can't use geometry, but I could cut them out and I could get a 3D model. Does that make sense what you're going to do? It's very visual, and you have to put invisible things on top of your paper and imagine them. I'll cut little papers out so we can see. It helps if you've got your 4 major formulas written down, the rest you know. So let's look at, whoops, that's not our paper. That's the one I did last block, where I scared the kids because I wrote something down wrong. Okay, so let's do this. It's almost the same procedure as yesterday, except yesterday you looked for area, so you took the integral of kind of a linear. Now you're going to find the area, and then you'll integrate that so you can get volume. All right, so let's read this. If f of x, and I'm going to, is the square root of x, I'm going to put that down. I really do think if you can color code, it's going to help you a lot so you see what's where. Between 0 and 4, find the volume of the solid whose cross sections are squares perpendicular to the x-axis. Okay, so we've got this space right here. Just a 4, all right? And what they've told me is I have squares. So I've got a square cut out. Let me make that a little bit smaller. I've got a square cut out, right? The top minus the bottom gives me the edge of the square. And I'm going to stack these up all along here so you get a 3-dimensional object, right? Kind of like a little house, because it goes up, over, and down, only it will get smaller as you come down, because if this length gets smaller, the height gets smaller because it's a square, right? Does that make sense? Right? Okay, so let's just run through this and we'll see what happens. Okay, it's first thing I want to do, perpendicular to the x-axis. That means it's dx. Therefore, equation should be y equals, which it is, so we don't have to adjust it. If it's a dx problem, you need y equals x something. If it's a dy problem, remember we have to get x by itself. So is this done? Yes, I have y equals. Check. I don't have to make any adjustments. What comes next? Well, I got to find how big the side of that square is. If it's a dx, that's top minus bottom, right? And I can clearly see that my top is pink, so I go look at the pink one. Minus my bottom is yellow. So what does that square root of x mean? What that is, if this is my square, then this is the square root of x, right? It's the distance from here to here. Well, if it's a square and this side is the square root of x, how big is that side? Square root of x, it's a square. And what's the area of a square? Side squared. So let's do number 3. So first we decide which way it's going, right and left or up and down. Then we're going to say, how big is my side? Once I know how big my side is, I'm going to figure out how big what my area is. So what's the area of a square, just in general? What's the area of a square? Side squared. Well, we happen to know what the side is. So the area of our guy is side squared, which equals x, right? When you square the square root of x, you get x. The fourth step is to do what? What do we do now? What are you going to do to area to turn it into volume? What action are you going to take? Integrate. Take action. Integrate. So here we go. So all we have to do is put our area here. And that gives us volume. Now I have to figure out what numbers go here, right? But they already gave me that. Let's color code that 0 to 4. Now I'm going to do this one by hand because it's so easy. What do you get when you integrate x? You have x. Now there's a 1 in front, so you got a 1. Power up, power up. That's not bad, right? And then we go from 0 to 4. So we're going to plug 4 in. What's 4 squared? 16 divided by 2, 8, right? Minus, you plug 0 in here, you get 0 equals 8 units cubed because it's volume. How do you do it with your calculator? Everybody have your calculator out, and you're going to do math 9. So practice with a math 9. If you don't have a calculator with you, you need to remember to bring one next time. But where can you get one in your phone? Yes. Whoops, I'm looking for it right now. Well, I can never, okay. So if you'll do calculate 84, you should be able to do that math 9. Okay. So use your calculator. I want to see you really working. Don't copy what I have. Because what if I punch it in wrong? Or y'all are all athlete. A lot of you play in a sport or a music of some kind. Can I get good watching someone play the piano if I don't play? No. Can I get good at anything if I watch it? No, I've got to actually do it. So y'all use your calculator or your phone and make sure that when you type in math 9, you still get 8 units cubed. We have to get the same answer. We'll use our calculator today. I just wanted to do one by hand because I don't want you to forget the big idea of integration is what? Power up and divide. That power up is what reminds you. Linear powered up is area. Area powered up is volume. That helps make it make sense to you, I think. All right. You ready to try number 2? Okay. The region S is bounded by the graph y equals 2x squared and y equals x. Again, this will keep me from making an upside down mistake. Trust me, I could do it. Find the volume of a solid whose cross sections are semicircles perpendicular to x. Perpendicular to x tells us that it's a dx. Therefore, equations should be y equals. Are both of these y equals? Yes. So we have completed that task. I actually have a slab that looks like this. So imagine this is your driveway in front of your house, and this is the shape of your driveway. But instead of putting a car on it, you're going to put semicircles. So that's like this shape sticking up out of there, right? All right. What is step 2? Find S. What is S going to be? Top minus bottom, because it's a dx. What is the top equation? Two minus x squared minus the bottom. And what is the bottom equation? X. Now here's what I want you to think of in your mind so this works out. What shape are we working with here? What shape did they say? Semicircles. That's a semicircle, right? Half a circle. So when you subtract top minus bottom there of this semicircle, what part of the semicircle are you actually finding? What part of the semicircle is that? Come on, what part is that? It's the diameter, right? It's the diameter. But lucky for you, we have a formula, right? So what is the area of a semicircle? Now I know it's a circle divided by 2, but we're not putting it in terms of the radius because we found the diameter. So you have that on your Post-it note. I've already simplified this formula for you and accounted for the fact that it's only half a circle. There we go. You can remember this. It's always going to be a semicircle is kind of like a square, only pi over 8's in front of it. And that's not really a new formula. We just took pi r squared, divided it by 2, and realized when you square r and then multiply by 2, you get an 8, right? 2 times 2 times 2. Okay. So we have the formula. Therefore, what is our area formula? It's going to be pi over 8 times what squared? Right? You just put your S in there. And while you do your homework today, have a piece of paper and write your 4 steps down. If you can get a system going, you'll be good. Does that make sense? It's 8 over pi S squared, and we figured out S, so we put it in there. Everybody good? Write some notes to yourself and explain what you did. Now, how do I turn area into volume? What action are you going to take? Integrate. There we go. So I am going to say volume equals, I'm going to put my symbol here. Now, pi over 8, is that a variable or is that a constant? It's a constant, it's a number. So am I allowed to factor it out here? It's kind of easier to type it into your calculator if you type this before you hit Math 9. It's easier to type and not make a parentheses mistake. So all I have to do now is say it's area squared. So now I want you to notice, and I'm going to write them in so you see them. Your calculator is automatically going to put that there, parentheses and a D. So if you want to square something in here, you're going to have to do this. Okay, the black part is what your calculator automatically puts in. So be aware of that. It will not allow you to put a square in between this parenthesis and the dx. So you have to put that kind of like an extra set. Then we're going to put our numbers on. If we can clearly see them, we may use them. If we can't, we have to set the two equations equal to each other in y1 and y2 and find the intersection with math 5. We can clearly see these. It goes from where? -2 to 1. So -2 to 1. So now you're going to type that in, Math 9, and tell me what that equals. All right, everybody try it. See if you got what I got. I could make a mistake. It's possible. How's this going? Good? Are you typing it into your calculator? I don't see thumbs moving. Come on, people. So let's run through our steps again. We decide if it's right and left or up and down. We have to know that, standing up or laying down. Then we subtract our curves to get the length of the side. Then we go to our formula sheet to see what the area of that shape is. Then we plug our number in for S. All your areas have an S. We replace S with what we found. Then we integrate area, and that gives us volume. Is that okay? Make sure you're okay, because these are up and down, and we're going to side. Are you good? Okay. 2 more, and then we'll practice. Okay. Here's our shape. Let's color in. We know this is going to end up being your driveway, right? We just got to see what kind of structure, little building you're going to put on there. All right. Consider a region S bounded by y equals e to the x and y equals x. I'm going to put this here. I just can't work without my colored pencils. That one's gone. Okay. The region of the base is of a solid. Find the volume of the solid whose cross sections are perpendicular to the y-axis. What does that mean? Hold on, I want to make sure I stay with the same colors. Okay. What does that tell you? Is it a dx or a dy? It's a dy. So dy's are going this way instead of up and down. What does that mean for you? Equations must be what? In the form x equals. Do we have x equals? We do not. We need to fix these. Let's do the yellow one first. How would I change this to get x by itself? What would it be? Yes, x equals y minus 2. That's easy. Move the 2 over. Remember, if it's dy, you've got to have the equation written this way. All right, what do I do with this now? I got to take you back. How do I get that x down? No, we got to go back to pre-cal. Got to go back to pre-cal and algebra 2. How do you get an exponent to come down? What? I can't hear you. No?
You have to like put an exponent on top of the other number.
No. I'm going to log both sides. What happens when you log both sides? It allows you to bring this forward. So I end up with ln y equals x ln e. Now, what's the value of ln e? Remember what that means. ln e means there's an e right there. ln means there's an e. So this says e to what power is e? E to what power is e? 1. So what does ln e turn into? 1. We like ln e. Remember those from your applications of logs, the business problems last year? So ln e is really just 1. So now I have that set up. So therefore, x equals ln y and x equals y minus 2, right? Now this is my yellow one, right? This is my, well, I shouldn't have wrote in pink. That's my pink one. I want to keep them straight. I didn't change the equations. I just isolated the x. Okay, we got that taken care of. What color? I did purple next. So S equals what here? It's not top minus bottom this time. What is it? Right minus left. Which one of these equations is on the right? The pink one or the yellow one? The pink one. So I know to go get the pink one. The yellow one is on the left side, right? Now I don't have to actually write it like that. I can distribute the minus, get rid of extra parentheses and say ln y minus y plus 2. If you forget the parentheses, there's a high chance you'll write y minus 2 over there, right? What color did I pick next? Dark purple. Okay. Now, these are isosceles right triangles whose hypotenuse is on the plane. Which one of these formulas are you going to use? The leg or the hypotenuse one? What does it say? Hypotenuse. What's the hypotenuse formula? So the area is, this is probably a new one for you. I know it's new. Right? We wrote it down on our Post-it notes, so it's easy for us to see and we don't have to stress. We'll have that out when we take a test. I know what the area is. So can I convert that now? Do I know what S is? Yes, we figured out S here. So area equals 1/4 times squared. Is that good? What am I going to do after I know the area? I'm going to integrate. That's my action to bring area up to volume. So I'm going to say, I'm going to write integrate down. Every time I write it, it helps it stick up here. Volume equals. Now there's a 1/4 out front. Am I allowed to factor that out of my problem? Yes. And it is much easier to type that in, then do your math 9 and get this. Now, the area, I just have to copy it. Now remember, Your calculator is going to put a set of parentheses. You need to do your own. Because you want to square that. Is that okay? And now it is a dy problem. Remember, if you forget to switch your equation, you would have x's in here, and you would be telling me dy here because you made that decision early on. If these letters don't match up, you know you forgot to fix your equations. It's like a little safety net. Now I have to figure out what goes here. Tell me about the numbers that go in those boxes. What value is that going to be? Come on, peeps. What value is that? This is a dy, so what goes in here? Y values. Y values. So I need the y value right here, which is not at 0. And I need the y value here, which is not quite at 3. So how do I figure out what my values are? I have to set the equations equal to each other. Now you can go back to your original equations, because to put them in the calculator, your calculator is going to take it as a y. It doesn't matter. We did not change these equations. We just rearranged who was on the side.
Miss Coughlin, are you setting them equal to 0 because you don't know exactly where they...
I didn't set anything equal to 0.
Oh, I thought...
So you're going to go into your calculator. You've got to know, you've got to be able to figure out where these two guys intersect. So we're going to go to y equals, and we're going to put in 1. And we're going to put in the other one. Right? You just tell the calculator what the equations are, and you graph it. And there's the same picture. What I need are where do they intersect. So I'm going to go second calc 5. And I'm going to ask, I got to scoot this over, and then I'm going to ask the calculator. You just hit enter 3 times. Enter, enter, enter. So where do they intersect? I'm going to write the whole point down. Negative 1.841, comma, 159. Then I have to repeat that process, second calc 5, and I got to go to the other side. Just arrow over and hit enter, enter, enter. Make sure that you know how to do that. Practice with your calculator on your phone or your calculator. Now, what values am I going to stick in here? These two or these two? Since it's a dy, I want those values, right? Okay. Now you're ready to put that in your calculator. So type it in, make sure you have it right. I see people just copying what I'm doing and you're not punching it in. Even if you got to use your phone calculator, punch it in. If you're doing homework in a minute that's due before you leave, you better know how to type it in, right? Math is a participation sport. Woo. It is a sport, right? Causes you to get exhausted and yes, sir. So you'll type in 1/4, then math 9. So type in 1/4 because it's outside, then math 9. So take a second and do that. I'm going to pause this if you're listening at home so you have time to type it in. A good question just came up. Do you type in LNY? Well, you may if you wish. You can go to alpha 1 and it's a Y. You do not have to. When you type this in, you may type all X's. Your calculator doesn't really know the difference. It kind of does. Your calculator will turn it on its side, but because you rearrange the equations and got the numbers different, it's okay for you to use an X when you type it in. Your calculator more or less just sees variable when you type an X. The trick is you got it in the right format. So you may type in X. You can do Y if you like it, but it's harder to get to. All right, one more. And then you have 4 problems for homework, which is why you're going to get them done in class. Because you remember my new name, Miss Mean and Cranky. All right. The region S in quadrant 1 is bounded by the graph of y equals x squared. Let me color that. Right? And x equals 2. So that is what space? So this is the shape of my driveway now. And I'm going to put a structure on it. Right? A solid whose cross sections perpendicular to the y axis. What does that mean? Are rectangles whose height is 5 times the base. We'll address that in a minute. What does perpendicular to the y-axis mean? dy. Therefore, those 3 dots mean therefore, equations must be x equals. We're going to have to fix these. One of them is okay, but this one, how do you fix that? So we're going to say x equals the square root of y and x equals 2. That one was already okay. This is our pink one. This is our yellow one. All you're doing is rearranging this. You're not changing what it looks like. Now, I didn't put a plus or minus in front of that square root. Technically, it would be both sides, but our problem is only asking us for the positive side. So I didn't put the negative side there. So we're good there, right? Let's go to step 2. Step 2 says we need to find the distance, S. S is going to equal what this time? Right minus left. And you could clearly see that the yellow mark is on the right, so that's my yellow one. See how nice it is to have it color-coded? The left side is the pink one, right? That was easy. Now we'll go to step 3. Step 3 says to find the area. What is the area of a rectangle? Well, it's base times height, correct? Now, what did they tell us about this rectangle? We have the base. The base is what we're going to get when we subtract these. S is the base, right? How big is the height? How tall is the height? So what is this area? Base times height, so it's 5b squared. But we happen to know how big b is, right? If this is my rectangle and it's perpendicular to y, right? This is, I think you could see it well in these colors. So this is b. It can't be a number because it changes size as I move it. And this would be 5b sticking up out of there. Does that help when I make these so you visualize? I got all these triangles sticking up. So there's my area. Therefore, area is what? 5b squared. But how big is b? You can see there's not a lot of tedious stuff for you to write down. But if you leave anything out, the chances that you type it in right. And you don't want to type it in wrong because it's a little, takes time to type it in and you don't want to do it twice, right? What is the final stage of this problem? Integrate. I'm going to write that down again. I really want to remember that. Volume equals. We integrate area. Now that 5 is a constant. May I factor that out? Yes. And it is easier. Now, I got to remember my calculator is going to do this to me. It's going to put parentheses and a D. I have to fill that in. So I need a second set because it won't allow me to square out there. Now on this one, I don't have to put it in my calculator to see where they intersect because I can see that the bottom is right here and the top is right there. So what values are going to go in there? 0 to 4. And let's put a little happy arrow there. Remember Y values. That's the easiest mistake to make, or to me it is. And so your volume should be, punch it in, see if you get what I got. Units cubed, because it is volume. Remember, you're going to type 5, then math 9, and then put that guy in there. All right. Now there's 4 problems for us to do in Delta Math for work. Not bad. Good job. Have a great